First video of the semester. This is Coach Damaris here, ready to help you out. Go ahead and talk about rational versus irrational. This is a great warm-up that we had, and I figured I'd make a great video for you, just in case for some students that understood this and some students that didn't. It's a great way to just kind of go back and refresh ourselves, whether we knew it or we didn't. So feel free to ask questions in the comment box. I would subscribe here because I'm going to be posting new videos probably daily. You can always ask me questions too in class or whoever is teaching you Algebra 1 this semester. Now let's go ahead and jump into rational numbers here. We have the square root of 15. Now something we need to know about these square roots. Essentially those numbers have to be perfect squares inside the radical in order to be rational numbers. So you have to see numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. If any of these numbers have a square root sign over them, those are all perfect squares. So if you have a square root sign over them, that number actually simplifies to be a whole number. So all of these numbers, again, those are perfect squares. So if this number is not inside or is not one of these numbers, then it's not rational. So you look at square root of 15, it's not one of these numbers, so that means this answer has to be irrational. That number is irrational. The square root of 15 is irrational because it is not one of these numbers. Now 3.7. 3.7 would be considered a rational number because it is a terminating decimal. Okay, it is a terminating decimal. I'm just going to put terminating there. Essentially what terminating decimal means that it comes to an end. There is a stopping point to the decimal. And as we said, 3.7. There's no number after the 7, so it is a terminating decimal. The square root of 33. Notice 33 is not inside these group of numbers, so it is an irrational number. 0.444. Well, that's the last 4, so technically it is over. That is it. So 0.444 is a terminating decimal. Now, again, just because I don't see an example of repeating decimal here, if let's say there was a line over that 4, or let's say they put a ... after that 4, that means those 4s are going on forever. And that would be an example of a repeating decimal. Okay, a repeating decimal is when a number, a decimal number, is going on forever, but it has to be either the same number or the same pattern of numbers. So keep that in mind when you're thinking about a repeating decimal. This right here, 1 over 3 pi, I'm going to be honest with you, anytime you see pi, go ahead and put that in the irrational column. Because usually fractions are rational, but if you see pi, just go ahead and bring it to the irrational side. Obviously, the next one is pi, so that is going to be irrational as well. Square root of 2, notice 2 is not on our list, so that will be irrational. It will be irrational. The number 10. The number 10 is considered to be a rational number. It is rational due to the fact it is a natural number. It is a whole number, and it is also an integer. It is also an integer. So 10 is a rational number, and a classification underneath the rational is natural, whole, and integer. -6. -6 is also a rational number. It is an integer. Okay, it's not a whole number and it's not a natural number, but it is an integer. So that means it is rational. And I may have another video later on just the difference between natural, whole, and integer. So be ready for that one. 1/3. 1/3 is a fraction. Anytime you see a fraction, just know fractions are rational, unless you see something weird in them like pi, or you see radical 33 in there. In that case, it would not be a rational number. So, but usually all fractions are going to be rational. 2 pi, again, you see pi and you think irrational. Irrational. The square root of 25 is 25 on this list. Bam, there it is. So if it's on that list, then it will be a rational number. It'll be a rational number. .0007, almost 007, but we got 0007. That is a terminating decimal. There's no number after this 7, so that would be a rational number because it is a terminating decimal. This is a big number here. Those are commas. That's 234,123,098. That is just an integer. That's a whole number. That's a natural number. So that's all three. So that number 234, 123,098. Okay. So again, that's a large number. If you have that kind of money, please share with Coach Damaris. He'd be greatly appreciated or appreciative. So 1 4/5. Again, that's kind of a fraction there we see. So that will be a rational number. It'll be a rational number, 1 4/5. I want to say that's a negative right there, a negative square root 5. But notice square root of 5 is not even over here. So just by knowing that, that will be an irrational number. An irrational number. Whether it be negative or positive, it's still irrational because it's not one of these numbers. It's not a perfect square. The square root of 45, again, is not on this list, so it has to be irrational. And the square root of 17 is not on this list, so it has to be irrational. Okay? So again, just kind of recapping here with rational numbers are either terminating decimals. Notice they come to an end. The decimal has an ending spot. A repeating decimal where it repeats either the same pattern or the same number forever. All right, so our example here was 0.44. I just put a line over the top just to show that it was repeating. You'll also see decimals at the end, sometimes 3 decimals. That means that it's going on forever. Then we have natural numbers, whole numbers, and integers. I'll make another video real quick on that. But just know natural numbers start at 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and keeps going forever. Whole numbers start at 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then integers are both positive and negative, like whole numbers. So, -3, -2, -1, 0, 1, 2, 3. All of those would be considered integers. So again, like, subscribe. Again, I'll be posting more videos in the future. Hopefully this benefits you for the upcoming quiz and hopefully the test to come.